Hi, my name is Shed Kedari. I'm a software engineer and a data architect at Hanumayamma Innovations and Technologies. I've been working since 2016. Here is our Sriya AgriVet Monitor. This is world's first monitoring system to monitor temperature, humidity, movement, rumination activity for animals and provide animal welfare uh, to understand the health of the animals. Here I'm going to, before going to deep dive regarding the models that we implemented, I would like to explain what Shriya AgriVet Monitor does. Shriya AgriVet Monitor is a welfare first monitoring system. It continuously measures temperature, humidity, movement, rumination, and activity. It forecasts environmental conditions, simulates extreme scenarios, and highlights departures from an animal usual pattern. Everything is built for real shelters. All we need is simple laptops, internet connectivity, and high welfare stakes. Data integrity is strict. Nothing is cleared from the sensor until it's safely uploaded. And every forecast is logged in an append only audit trail so veterinarians and trustees can trust the records. Now let's deep dive how the system works. The system uses a set of lightweight field deployable models. They are designed to run on a shelter laptop, not a cloud cluster, and they are engineered to be safe, interpretable, and auditable. There are four core model principles. First, profit model. Here is how we implemented profit model and also other models. So here is a sample code that explain how we implemented it. And we also log all the forecasts, and here is how we log. Here's the Python scripts. Coming back to the models, there are four core modeling principles. First, profit. Profit model is to understand the environmental forecast in three parts: trend, daily cycle, and uncertainty band. This keeps the model simple, explainable, and robust. Second, the trend damping. Once the forecast horizon exceeds the data pan, we damp the trend. Beyond twice the span, we hold it flat. This prevents invented numbers and keeps the forecast honest. Third, derive signals and not fitted signals. We derive THI from the temperature and humidity instead of fitting it separately. This preserves the correlation between the two, which is essential for each state prediction. Behavior baseline instead of behavioral forecast. Rumination and activities are not forecasted. We show here visual range built from own history, and departures or findings are identified. This avoids false claims about behavior that no model can reliably predict. So here we can change the temperature, and I try and play with the model to identify if a temperature or humidity or both updated, then how the model behaves. Now let's go deeper into the model. First, I'll start with how we implemented regression model. Linear regression is fitted is used is used uh, to, to understand what how the data is fit. So we fit the linear regression to daily medians, but only when enough data exists to make the slope meaningful. If the slope is based on too few points, it's just noise. To prevent false trends, we apply three guards: standard error testing, minimum day requirements, and damp exploration. Standard error testing. We compare the slope to its own standard error. If the slope is ingestible from 0, we shrink it to 0. Second, minimum day requirements. A real trend only emerges once enough days support it, typically 6 or more. Third, damped exploration. Even the valley slope is damped as the forecast horizon grows and flattened beyond twice the data spans. Now let's look more detail from temperature to rumination. Let's start with temperature. The black points that you see here uh, are recorded temperatures. The orange line uh, or orange circles are immuted values, about 10% of the data, and the pink shaded region is the likely range. The daily cycle: warm after sunrise, cool after dark. It carried forward. Across days, the trend is slightly cooling, about 0.1 degrees per day. But once the forecast horizon exceeds the data span, we damn that trend. But once the forecast horizon exceeds the data span, we damn the trend. Beyond twice the span, we hold it flat. That prevent invented numbers and keeps the forecast honest. The rolling backtest over 14 origins shows strong reliability. MAE around 1.4 degrees, RMSE around 2.0, bias essentially 0, and 99% of readings inside the likely range. Here is what you can see. Now let's go with humidity. There is no meaningful trends across days, so the model carries forward the only daily cycle. Record points are in blue. The rolling backtest shows MA is around 3.5% RH and RMSE is around 4.9%. Bias is slightly negative. The model tend to underpredict humidity by less than 1%. 98% of readings falls inside the likely range. Data completeness is nearly 90% and forecast confidence is moderate. So here is a table for temperature and humidity and how the MAE and RMSE looks like for next day, 3 days and 7 days. For temperature, the MAE is 1.39 degrees centigrade and RMSE is 2.07 degrees centigrade. Bias is 0.00% degrees inside range, so quality is high. Temperature for 3 days 1.54 MAE is 1.54 degrees centigrade, RMS is 2.25 degrees centigrade. Bias is minus 0.02%. Inside range 100%, the quality is moderate. And this is how the charts follow up. Till now we looked into temperature and humidity. Now let's look into activity. Here is a graph for the activity of the cattle, and here is the blue line shows the recorded, and here is the range predicted here. Let's go with heat stress. We compute the THA from the forecast temperature and humidity for each hour. This preserves the correlation between temperature and humidity, which is essential for accurate heat stress prediction. Record THI values are in blue. The likely range is in brown. And on the right, you see the moderate and severe heat stress zones. Now, data completeness is 89.9%, imputed is 10.1%, and missing is 0.0%. Computed from the forecast temperature and humidity, not fitted on its own. Now let's look into rumination. Here is a rumination pattern, and it's important to emphasize that this is not forecast. We have taken 16 days of data and calculated the rumination. We identify the rumination readings and show the range and normal how it normally keeps. Any departure from this range is finding, not an error. Movement affects rumination. High movement usually means less rumination. Low movement could be rest or could be illness. So we widen the band on both sides rather than claiming we. This pattern assumes her ration did not change. Ratio did not change. Feed is not measured by the sensor, and feed changes affect rumination more than the weather does. So departure during the feed change is a feed change, not a welfare finding. This is the overall implementation and how we use advanced AI models to provide welfare for animals, and I help them to recover from any different things. Thank you very much.